stack researcher. So he does a really good job of getting down into the details on the engineering analysis. He does a lot of economic analysis, behavioral economics. But then he also is, co-author on these studies that's really looking at the big picture, looking at, where we're headed over the coming decades, and does it in a very relevant and salient way for thinking about the sort of trends in sustainability and emissions and low carbon transportation options, but also policy relevance, right? So he does work and produces research and blog posts that are just really interesting and informative for anyone who's trying to think about this and think about what are the kinds of decisions we need to make as a society in order to, bend the needle a little bit on our emissions trajectory from transportation. And I think I appreciate where you've come so far and where you're going. I just want to also give you a flavor for some of the recent work that Don has done, and I'm sure he'll cover some or all of this in his presentation, but I'm just going to read 3 paper titles from the past 2 years that he's been involved with. So one is Help or Hindrance, Travel, Energy, and Carbon Impacts of Highly Automated Vehicles. Racial and Gender Discrimination in Transportation Network Companies. That one got a lot of press, was very, very interesting. Complement or Competitor, Comparing Car-to-Go and Transit Travel Times, Prices and Usage in Seattle. So without further ado, take it away, Don.
Thanks, Colin. That was by far the most generous introduction I've ever received. Sets a high bar. So thank you very much, Colin. So our group is the Sustainable Transportation Lab at the University of Washington, and I have a great group of students. Actually, some of these have left. Michiko just went to Uber, actually. We've got some new students coming in. But I always try and acknowledge my students and collaborators when I'm sharing our work, because it really is a group effort. And so when we think about sustainable transportation in our work, we really try and think about sustainability as not just environmental, which is, I think, where a lot of people's mind goes when you say sustainability. We think of it as both an environmental, but also an economic and a social equity goal or aspiration that we're aiming for. And that we try to keep that in mind and inform our research directions, given that definition of sustainability is encompassing all of these dimensions. And so, we do look at a range of questions, some of which span between 2 or 3 of these areas, some of which are kind of squarely in one of these circles. The topics that I want to talk about today are a couple of the ones Colin mentioned. So looking at car-to-go and how it's kind of comparing and interacting potentially with transit in the Seattle area. Looking at Uberhop, which was a service that Uber trialed in Seattle and Toronto last year, and is still running in Manila in the Philippines. And also some work that we've done looking at Uber and Lyft and whether they equitably serve different types of neighborhoods and travelers of different races. We do other work as well. I'd say our biggest other research area is on EV charging, so developing sort of applying travel behavior analysis to the charging decisions of EV owners, and then looking to sort of extend those and apply those to forecasting the future growth of the charging station market and understanding what we need to do to kind of grow the EV market concurrently with the charging market. And then an area of intense personal interest to me is, the effects, the looming effects of automation on travel demand and energy and emissions. That's not something, so these topics over here I don't really have anything with me today to share with you. I think we talked it through and decided that, a nice theme would be kind of focusing on these mobility as a service or shared mobility topics. And the kind of the structure of the talk is that I don't really have like one grand narrative, but rather kind of a sampling of these different topics, kind of give you an idea of some of the different research that we've been doing. So the first of these is looking at Uberhop. So Uberhop, this is work that was done by Elise O'Callaghan-Lewis, who's a master's student at the University of Washington. Uberhop was actually, how many of you know what it was or is? Okay, so I will explain it. It was kind of a variation on UberX. They used UberX drivers, mainly in larger vehicles, crossovers, minivans, or SUVs. And they were serving fixed routes, providing a direct A to B service from a set pickup location to a set destination, low fixed fares, and it was on demand. So it's sort of approximately like real-time van pooling enabled by the Uber app. And the way it worked was that you would, as you do when you use the Uber app, you could select hop from the menu at the bottom, and then when you did that, you could then select your route up at the top. And so when you select your route, that has a specific pickup location, specific drop-off location, and it's going to be, again, it's this A to B service, right? They're not making stops along the way, so it's a little different than like the Lyft bus that you're seeing now. And then the idea is, so suppose you request it, it starts this countdown timer, and so they guarantee a 10-minute headway, meaning when someone requests it, if you're the first person to request the trip, then they start this 10-minute countdown timer. After 10 minutes, that vehicle's leaving with you in it. In the meantime, if anyone else wants to make the same trip, they'll add them to that vehicle. So it met with mixed reviews when it debuted in Seattle. It was generally presented as a carpooling service, as a tool for reducing single occupancy vehicle commutes. This is kind of how Uber presented it. This is how some of the media picked it up. Other media were less charitable, saying that they were trying to kill mass transit. And actually, Mike, I'm curious, like, how many of you, okay, leaving aside whether Hop was really going to kill transit or whether Uber really wants to, like, how many of you think that killing transit would be a bad thing? Does anyone think it would be a good thing? Well, it depends, yes.
In suburban areas.
Yeah. So I mean, I think this is funny, like all editorialize, but I think a lot of people say this, like killing mass transit is like it's an obviously bad thing, but I think a lot of mass transit as it's currently used is kind of, in a sense, unsustainable because it's such a huge money loser. And in many ways, you could meet these services more efficiently with TNC type services like UberX. Spoiler alert, Uberhop is not a good solution here because it was going really after the jugular on the most profitable routes, the routes where it really does make sense to be using, big buses. So what we did, we kind of wanted to know, was this actually something that was helping to reduce SOV commutes, reduce greenhouse gases? Was it economically viable? And if you try and work with Uber, it's really hard to get data, so we just went out and did this ourselves. Elise had really the right person for this. She's got the right personality to go out. She did this intercept survey. She intercepted 100 Uberhop passengers, which doesn't sound like a lot, but it was like all the passengers on the routes she was studying. So, and she had 83 out of 100, 83% response rate. So they're running 11 routes, and they run two directions, right? Morning peak, they run one direction, PM peak, they run the other. So she's out there for sort of 22 study routes. And over that, she observed, she gets 100 passengers on these 11 routes. Because some of these, you see like Ballard up there in the top left, because that's serving multiple destinations, when she's out there handing out her survey, she's also able to kind of count how many people are getting on these other routes. So she's able to count a total on sort of additional routes. She counts 165 passengers on 133 vehicle trips. And the reason but then she's given out the survey, and then we had an assistant for her at the destination point. So we think that was kind of part of the reason we were able to get such a high response rate. It was really easy. It was a one-page or two-page paper survey. She gives it to them when they're getting in the car. They're just going to be sitting there, and they give it to the assistant when they get out. And this was, as I said, summer of last year. So the first thing we found was, not surprisingly, overwhelmingly people were walking to and from Hop. and this was overwhelmingly used for making commute trips. And the demographics tilted young, male, educated, and wealthy. You know, the median household income in Seattle is about $75,000. So, you know, this is not as extreme as it would be in a national context, but still 77% above median income, 93% bachelor's degree or higher. And the reason is they really, if you look at the areas they're serving, you know, the shaded areas are areas with high levels of minorities. The ones that are highlighted with highlighted borders are lower income areas. And so they're really primarily serving non-minority and non-low income areas. The one that they're serving here, that is where the Starbucks headquarters is, kind of plopped right in the middle of that track. So that's what's happening there. So they're really kind of targeting those areas. Now, we wanted to understand what were people using, what were basically, because this is a new service, what had people replaced when they started using Uberhop? And so we asked two questions that kind of get at this. So one was, what is their primary form of transport for this route on most weekdays? And the other was, imagine for a moment that Hop was not available today, how would you have made this trip? And what you can see is that for almost half the sample, Hop had become their regular, their go-to mode. And then, but when you take Hop away, where do those people go? Well, they would have, most of them would have been taking the bus or rail or another Uber instead of Hop. And so when you look at this, it's actually a majority of them basically had come from either for bus or rail. Driving, it's pretty small. Driving or getting a ride are pretty small. So this really didn't appear to be something that was competing with SOV commuting. We also asked them why. This is a lot of words, I'm sorry, but this is the list of reasons that they gave or the list of reasons we gave them, and they ranked how important they were for their decision, and sort of ranked them from not at all important to very important or important. So basically the bigger, right, so the more you got over here, the more important it was, and we've ordered them from most important to least. And so the big things that they noted really had to do with travel time or ease and fewer transfers. And the reason is on these routes, you know, it's a lot faster to travel by car than it is to travel by transit. So it's a big time savings. But also right up here at the top, lower costs of the trip. So Uber was pricing these on half the routes. They'd price them less than a peak hour bus trip. So peak hour bus trip on King County Metro is $275, and they'd price them these at $250. So not terribly surprising. Again, the large majority of these were in an SUV, minivan, or crossover, so these are larger vehicles. But 80% of the trips were taken by a person traveling, or one passenger. And the average is about 1.25 per trip. As I said, right, 165 passengers, 133 trips, 1.2, 1.25. But it was really just a couple of routes that had high ridership. So South Lake Union here is where the Amazon campus is. Ballard and Capitol Hill are a couple areas where a lot of tech workers tend to live. And so those ones are getting 1.4 per trip. The other routes, the average is 1.1 per trip. So this is not really functioning very well as a carpool service. So we looked at the greenhouse, we looked at sort of what are the average per passenger mile greenhouse gas emissions. You can see that, of course, your average emissions go down as your ridership goes up. You know, they're up here. On average, they're higher than a 25 mile per gallon gasoline car. Well above, you know, driving alone in a Prius. And, you know, you look down here, this is sort of the average, peak hour average for King County Metro on their busier routes, even at 4 miles per gallon. And so what you can see is that if they could get their ridership up to 4, 5, or 6 people per vehicle, this would make sense from a greenhouse gas emissions perspective. But where it was not really doing anything. It was arguably counterproductive. We also looked for the Ballard to South Lake Union route. tried to figure out, we kind of gathered from various sources that, basically what Uber was doing, because these guys were mostly just sitting there, Uber was sort of guaranteeing them an hourly rate if they chose to be sort of available for the hop service and to be on call. So in order to kind of make them whole in terms of their hourly earnings, we figured out how much Uber would have had to be subsidizing them. And we figured that Uber was probably losing, $15 an hour or so on these routes. It's not going to break Uber, right? But it's certainly not helping them either. But again, if you could get this up, if they could get this up to sort of 4 more people per trip, they could probably break even or make money. So the way it was implemented, the question was it sustainable? The question was not really in Seattle, not by any measure. Sort of the markets they're serving were very inequitably distributed across different neighborhoods. They're pulling people mostly off of transit, and they're running these things, as close to empty as you can run them just about. And so you really need to get this up above 4 riders per trip to make sense economically or from a greenhouse gas perspective. So that's that. And I will move on to pretty much to a different topic. But I guess on the question of equity, maybe that's the segue, right? So, and feel free to interrupt with sort of clarifying questions. Yeah. Yeah. How does it help them in their revenues? No. This is sort of, again, thinking of sustainability as something that's going to encompass economic, environmental, and equity dimensions. If you want it to be sustainable, this makes the economics and the environmental or the greenhouse gas numbers work. And then, this is sort of, don't forget about that, right? I mean, that's debatable. Yes?
Have you been following Uberhop in Manila?
No. I bet Elise would love to go there and, and collect data. But no, have you?
No.
Okay.
I'm hearing about it.
No, sorry.
But I'm just curious if it's still in operation.
I checked this morning, and the latest that I could find was that it was. But it wasn't like from yesterday. Sort of the last, Google hit I found was something that was referring to it as still in operation. Yeah, and I think it's probably a matter of it makes more sense there. They probably have greater density and greater density of demand for these services. But equity is a good segue. So I think Colin also mentioned some work we've done assessing discrimination in transportation network companies. And so we've done sort of 2 pieces of work in this area that I'll go through here in sequence. But it's first helpful to kind of think about, if you think about equity and opportunities for discrimination in transportation network companies, TNC Services, there's sort of, as far as we can tell, about 4 main ways or 4 main opportunities that are places that this could take place. So one is, where does the driver go? Does a driver systematically avoid certain types of neighborhoods, right? So that could have a disparate impact on people who live or visit those neighborhoods. The next is drivers can make a decision about whether to accept or reject a request, or after accepting a request to cancel that trip. The third is they can make choices.
The driver does not have knowledge of the destination. You said, in the first thing you said the driver might reject the ride based on not wanting to go to a place, but the driver does not have knowledge of the destination.
They know where the pickup is.
Pickup,
Yeah.
Okay.
So they might. So one thing is they could decline. They could decline a trip when the request comes in based on where the location is. The other thing is they can avoid altogether certain neighborhoods. So like a taxi driver, and a friend of my friend is a taxi driver who does this in Chicago. Drive through certain neighborhoods. I don't want to pick a fare up here, turn off the light. Well, the modern day equivalent of that is you go offline, you turn the app off while you're going through a certain neighborhood. I've read also you go on, you learn a lot reading internet forums where drivers talk about this, but guys talk about how certain parts of LA, they'll turn the app off because once they get in there, they never get out. They'll get a request for a short trip, another short trip, another short trip, another short trip. And they don't like those because they make less money on those really short trips. You've got the same deadhead but less revenue miles, so they don't like those. But no, they don't know the destination until the pickup. That's right. Once they've got a passenger, they could presumably exercise some discretion over the route they take and maybe the quality of service or interaction they provide. And then at the end, right, they give a star rating. That star rating is important because that affects your ability to get future rides. So the first study we did of this, we focused on this, just this first piece, and we looked at Seattle, and we looked at basically how long would you expect to wait for an Uber in different, across different neighborhoods in Seattle. So this work was done by Ryan Hughes, who's graduated in 2015, and we published it last year in the Journal of Transport Geography. So we can kind of, we collected about 1 million observations through Uber's API of the waiting time across locations throughout the Seattle region. So the whole, at the time, pretty much the whole Uber service area in Seattle and the suburbs. And we wanted to know, looking at sort of density, employment density and residential density, as well as the fraction of minorities in a neighborhood and average household income in the neighborhood, do those, are waiting times kind of systematically longer or shorter? And that would tell us if drivers were kind of avoiding the, it's not a perfect answer, but it gives you some idea of whether drivers are systematically avoiding certain types of neighborhoods. And so what we kind of expected was that you'd see longer waiting times in lower income and lower income areas and areas with more minorities. That's not what we found though. So the first thing we did was, so what we did is we used a spatial error regression model, or a set of spatial error regression models to basically see how waiting time correlates with population density, employment density, minority fraction, and household income. And what we found is sort of controlling for everything else. You see these effects, and we sort of estimated different models throughout the day. And what you see is that, right, this is negative, so shorter waiting times in areas with higher population density. And that's more or less what we expected. What was interesting was that you see that effect gets closer to 0, it gets smaller in magnitude during the AM rush, more or less. So we thought about that. We thought, okay, that kind of also makes sense. If there's lots of demand, then that's basically pulling cars out of the available pool in those areas. It makes sense. And then you see kind of a similar effect of employment density, right? Higher employment density is also associated with shorter waiting times. But you see that effect kind of gets smaller in the evening rush. Again, when people are leaving work, they're basically pulling those cars off the road, or pulling them out of the available pool. So that's how we interpret these. But then this was really kind of what we were most interested in. So on the left here, this is the effect of the fraction of minorities in a neighborhood. So more minorities in a neighborhood, sort of for part of the day, does not have a significant effect on waiting time. Sort of in the middle of it, or morning hours, late morning, it's shorter waiting times. Late at night, it's associated with longer waiting times. Right, so is that good? Is that bad? I don't know. You average it out over the course of the day, and it's pretty close to zero effect. But then what we thought was quite interesting was that lower income or higher income is associated with longer waiting times pretty consistently throughout the day. So what we took away from that is that, it's not like you have to be in a white and wealthy area to get sort of a shorter wait time from Uber. In fact, it seems that higher income is associated with longer wait times.
Is this a supply factor or a demand effect?
Well, we don't know, right? There'd be a bunch of different ways you could dig into that. I'm not sure what they all would be. One approach would be simulation, and if you could sort of simulate the demand for these trips. So we were talking this morning about the work that the CTA did, the SFCTA. Sorry? So we don't know, because what we were able to get out of the API was waiting time, and so I wish we'd gotten surge pricing too. I wish we'd gotten pricing. We didn't at the time. This is one of these, it's a terrible excuse, but it's sort of like, well, you know, this was Ryan's project and you graduated and I think you did a great job for a non-thesis master's student. But there's only so much. Sorry? Yeah, so I mean, in a sense, yeah. So why is it? Is it because there's less demand or less supply? Or maybe there's less demand, less supply because there's less demand? So from an explanatory point of view, I don't quite have the answer. I think, though, you can think of it kind of from just a consequential point of view, which is, if you live in a lower income neighborhood, are you getting shafted? Are you waiting longer for an Uber? And this seems to say the answer is no. So leaving aside why that is, you know, it's sort of like, okay, well, at least we know that, you know, lower income does not tend to have higher weights. And of course, right, this is simultaneously controlling for density, but the lower incomes, income is negatively correlated with density, so higher income tends to be lower density. So if you're a lower income person, you're getting this effect plus probably the, you know, on average the effect of being in a higher density area, which also is shorter wait times. So yeah, we don't quite know why, and there'd be different ways you could explore that. If you wanted to do it with data rather than simulation, you'd need to get trip origin data, the number of trips initiated. So that's what this SFCTA study did. And I guess my friends from the lab were saying that Uber and Lyft then pulled down that data off the API after they saw what SFCTA had done with it. So that's not available now. So I don't know, back to sort of coarser data that just gets reported to the city. So looking at this first piece, you know, to vastly simplify, right? We sort of said, well, this seems okay, right? We don't see any red flags there in Seattle at least. So we did another study where we looked, and this was sort of bigger in scope, and we looked at these remaining 3 questions. And so this was work that I did with my PhD student Yan, and with Stephen Zoff at Stanford and Chris Knittel at MIT. And what we did here was we ran a field experiment, actually 2 field experiments that were not, it was not a replication. It was sort of, we did one, we learned, we ran another one that we thought was better. And we did one in Seattle, one in Boston, to see whether we could test whether Uber and Lyft drivers are discriminating based on race or perceived race of the passenger. And so I just really want to caveat this up front that, you know, where we find evidence of discrimination, we believe this is the actions of individual drivers, not something that Uber or Lyft is doing with their platform. And just because I say that it's drivers, that doesn't mean it's all drivers. It may very well be sort of a subset of drivers. And in any individual case, you can't say that this driver declined this trip or canceled this trip because they were discriminating based on race, right? Maybe they needed to get fuel, maybe they wanted to go off shift, maybe they needed a bathroom break. There are plenty of legitimate reasons. In any one instance, you don't know why they did it, but what you can see is sort of as you collect a larger number of observations, you see patterns that really can only be explained by discrimination. So kind of the backdrop for this, right, is that the taxi industry is sort of infamous for discrimination against passengers. And historically, this would be, you know, taxi drivers, you know, seeing a guy trying to hail a cab on the street and, you know, just driving by and not picking him up. And so this is sort of, it's funny, we had a really hard time. We didn't really find any systematic research on this. It's one of these things that sort of everyone knows is true from experience. And so even with a very small amount of data collection, we did sort of confirm that this is still a real thing in Seattle. So among other data collected in this trip, we collected a little bit on curbside hailing of taxis. So for you kids, in the old days, if you wanted to ride, you had to stand on the street and like wave your hand. If you're really talented, you could whistle, right? And I could never whistle, but you could whistle and you get the cab and the cab pulls over, and that's how you found your ride. And so we had RAs who went out in the field and did this, and they were like, "You want us to do what? Like you want us to stand and wave?" I said, "Yeah, you got to do it, and you all got to do it the same way. This is important." And so what we found was this is the cumulative distribution for the black travelers and the white travelers for the number of taxis that passed before a taxi stopped to pick them up. Yes, number of taxis passed, yeah. And so what you see is basically 60% of the time the white travelers in Seattle had had none pass them. So the first taxi stop, that was less than 20% of the black travelers had that. And basically none of the white travelers had more than 4 taxis pass them. And about 25%, or 20% of the black travelers had 4 or more taxis pass them. So that seems pretty straightforward to us. So this is an issue in taxis, but what we wanted to know is, like, as you move to TNCs, does that fix things, or does that just make it less visible? Does it mean you can't see the taxi driving by you? You just know that the guy declines the trip, and you never kind of see it. So what we did was we set 7 routes, and we sent our RAs on these assigned routes, sort of in loops out around the city of Seattle, starting and ending from the University of Washington, but covering most of the city. And so they had assigned origins and destinations, and we randomized the services that they were supposed to order. And what they did was, basically they took screenshots as they went. Very high tech, right? You take a screenshot, but it works. And so, oh, we should have blocked out the drivers. Oops. Anyway, what they would do is they would take a screenshot right as they'd request the trip and take a screenshot, so we'd know when that trip request got sent. They all had the same kind of phone. We issued them the same kind of phone, same data plan, same carrier, everything. Same profile, same kind of profile photos. They all had their photo taken against a plain white background, no smiling allowed. So really tried to control for that. And then they would have take another screenshot when the trip is accepted. So as soon as you get that confirmation, like your driver's on their way. And then when the important thing. So Lyft shows the first name and photo to the driver at the time of the trip request. Uber shows a first name, no photo, and they show it after the request is accepted, okay? So going forward, that's going to be important. These are details that, as I said, we ran 2 studies. This is something we improved upon in the second because we didn't fully exploit this in the Seattle experiment. Then they take another screenshot when the driver gets there to pick them up, and another one when they get dropped off. And of course, when you take an Uber or Lyft trip, you also get emailed a receipt showing the time and distance on the trip, and we also made use of that information. So we're able to use this and measure sort of what we call acceptance time. That's the time from request to dispatch. From acceptance to driver arrival, that's your waiting time, and then your travel time from pickup to drop off. And what we found was that black travelers waited significantly, statistically significantly, practically, is not a huge difference, longer to get their trip requests accepted in Seattle. We also tested Flywheel, which is like Uber, but it uses existing taxis. We found no difference here. But so the blue column is the waiting time in seconds to get your trip accepted if you're black, red is if you're white. And so the question is, why are we seeing this on UberX if the drivers don't see your photo, right? So we found this difference. We don't know what else could explain it, right? Well, we thought about it. We thought, okay, one thing is there could be differences in how, because we had 4 white students collecting data, 4 black students collecting data. Maybe they're just logging the data. Maybe they're taking the screenshots just a little differently, like they're not as quick on the draw. But it could also be that, rolled up into this average is that sometimes the trip gets accepted and then canceled. And we didn't really think that, who would do that, right? It wasn't really on our radar. But then students kept saying, oh, the trip got canceled, the trip got canceled. And so, again, this is something we learned in the Seattle study, and so we'll come back to this in the Boston study. But we did see these differences. We don't really know what else could be explaining it. And then the question is, well, why no difference for Flywheel? Maybe if you're a taxi driver and you like to discriminate, you're the taxi driver who drives down the street and looks at the person. You're not the taxi driver who uses the Flywheel app. That's sort of the only thing we can think of. And And then this translated into longer waiting times for Uber, but not for Lyft. And again, we're not totally sure we can explain that again, right? We don't know everything that's going on inside the system. But we ran a bunch of different model specifications to check robustness. We found that these longer acceptance times for black travelers were pretty consistent. And again, this longer waiting time for black travelers using Uber. And so, as we went to our second experiment in Boston, we thought about what we learned and what we didn't know in Seattle. And we we sort of decided we'd change the design of the experiment a bit, and we were going to focus specifically on cancellations. Because we thought that with Uber, it seemed like what was probably the likely mechanism was that drivers would accept a trip and then were more likely to cancel it if the traveler was black. And we were also a little worried about differences between our black RAs and our white RAs. So what we did was we had 4 RAs, or four women and 4 male RAs, and we had each of them assume 2 different names and create 2 different profiles. And these names, we didn't make these up. These are from, there's been research on discrimination in job hiring and so on, job interview callbacks and stuff. And so we pulled these names from there. And what we found was on Uber, right, and we were like, we said to the RAs, your job is like, do not take your eyes off that app. Like, if you get a cancellation, you take a note of it, right? And so on Uber, we found much higher cancellation rates, especially for males, and this was especially pronounced in low-density areas. On Lyft, where they see the name before they accept, we didn't find a significant difference, which makes sense because if they want to discriminate, they just won't accept the trip in the first place, so there's no need to cancel. This looks big. Turns out it's not statistically significant.
Just back to design for a second. Did you have to create fake pictures for these people for their name?
I believe we did not use photos in the Boston study. I would have to check, actually, because I can't remember if we used photos in the Boston study. So turns out Uber never shows the photo. So we decided my recollection is we just didn't do photos at all. So there's just names. So this is kind of what I showed you, right? Much longer times for black males, especially in low density areas. We also found longer trip distances for women in the Boston experiment, and about 5% longer. And sort of anecdotally, based on talking with our RAs, what we found was there's a whole bunch of ways that this happens. Sometimes the driver indicated the trip had started before they actually picked the passenger up. Other times the driver was maybe a little chatty or a little friendly with the female passenger. There was one young lady who said that the driver took her through the same intersection over and over. And on the 3rd time through, she was like, I think we've been through this intersection before. He was like, oh yeah. And then he went through it a 4th time. So we don't know if the drivers are trying to like cheat the women, or if they're just trying to like, it's like speed dating. They want it to be speed dating. But what was strange was we didn't find this effect in Seattle. Why? Again, we don't know, right? We can speculate, and I will. I'll happy to speculate. One thing is that in Seattle we have a pretty good grid road network, so it's pretty easy to tell if you're going the right way or the wrong way. If you were trying to kind of, as they say, take someone for a ride, take them on a longer route, it's really easy to do that in Boston. It's harder to do that in Seattle because you're going either north, south, east, west in Seattle. Boston, it's a mess, so you can, sometimes the fastest route will be out of the way, but we don't really know. The good news was the star ratings were virtually identical. These are the ones for Seattle. So across all the travelers and across the 2 groups, really no difference in star ratings that were received. Again though, right, you get a star rating from the driver that completes the trip. You don't get a star rating from the driver who didn't complete the trip. So when we look at this, this seems to be the area of most concern. There's maybe some cause for concern in this sort of, route choice area. And then the star ratings, again, seems okay. So we proposed a number of possible, ways that you might deal with this. And as Colin said, this study got a lot of press, and everyone really latched on to our recommended solutions, which were not recommendations. I should have known better, right? It's like if you float a possible idea, that becomes a proposed solution. And so we were really just kind of trying to lay out the range of actions that might be considered. I don't know if we got time to go into what could go wrong with all of these, but suffice to say, like almost all of these could help, but they could also have some real problems. I want to be aware of the time, and just if there's any questions on this, yeah.
One quick practical question. How did you get over IRB? You're using deception, and you are putting some drivers at risk by not giving them rides if they...
What's an IRB? No, I'm kidding. So this went round and round with the IRB. And we ran, actually, for the Boston study, you'd have to ask Steve or Chris, because they ran the Boston study through the MIT IRB. For the Seattle study, what we said was we really need deception, or is it deception or lack of it's not fully informed consent. It's lack of any informed consent, yeah. Yeah, does that qualify as deception? I don't know.
The MIT one was deception.
Right? Oh, because they're different names?
Absolutely, right? Yeah.
Sorry?
Yes.
Because they're different names, yeah. So what we did, we went to the IRB, we talked it all through, and what we said was that this was essential to the design of the research. So for Seattle, we said we need to know this. The IRB, I'll tell you, the thing they were most concerned about, and rightfully so, I think, was retribution against the drivers. Yeah. What we said was, number one, the drivers that we're going to have information on are not the ones you need to punish, generally, if anyone needs punishing. But also, right, it's that issue of, like, in any one instance, you don't know what happened. So you don't know if a driver canceled because the passenger was black or because of any long, long list of perfectly valid reasons. And they said, well, do you think that you would get enough repeat observations of the same driver that they could establish a pattern? And we said, well, we ran some numbers and we said we don't think so. And they agreed with that. But it was really that it was kind of inherent to the design, and we needed that secrecy because we didn't want the TNCs to know about this, and we thought we also didn't want the drivers to be in a position where a driver knew about it, and then the TNC would punish them for not telling the company. So we said that was in the driver's interest not to know what was going on. So that was the conversation with the IRB in Seattle. I don't remember it at MIT because Steve and Chris led that piece of it. So yeah. Yes?
In terms of opting the driver behavior, I guess this is like just an idea that you threw in the paper, but I guess you're supposed to catch some pattern that drivers exhibit when they are in fact discriminating. So going back to the diagram where you showed the average waiting time, I just wanted to, I wondered.
Wait, here?
So I wondered how much of the driver population that actually didn't accept. So did you ever put up a study the distribution of it, not the average? So like, for example, like UberX for black people, it's possible that they get more acceptance and longer acceptance time more often than the white people?
Yes, we did. And what you see is that, and I can't remember if we put these in this is an NBER working paper right now. I can't remember if we have the distributions in there in the appendices. But what you see is, like, at the high end, they kind of diverge more, which is sort of what you'd expect if it was, right? So at the low end, there's not much difference. But at the high end, sort of the shortest waiting time for a black person is not that different than for a white person. The longest is a bigger difference. So here we're just measuring means, but you did see that difference at the tails of the distribution more, and we did include some quantile regressions in the paper.
So even if the mean is not that different, they're more probable
so that it could be skewed out to the right more for the black travelers. Yeah. That's my recollection of how the data looked. I think it's in the paper. If it's not,
Do you
we'll follow up.
recommend any driver behaviors that kind of filter out?
Well, so driver behaviors. I mean, so right now, really, and part of the challenge is there's some practical barriers to this too, which is the TNCs are really constrained because they're very determined to keep their drivers classified as independent contractors. They're very constrained on how much they can tell, to what extent they can tell the drivers, like, you must do this or you must do that. So they have to leave a certain amount of discretion with the drivers, otherwise they'll no longer be independent contractors. Again, we didn't drill down into that. I mean, I think when we wrote that, we were kind of thinking you could basically, do something like what we did. You could assess the probability of race based on name, and then you could look, driver by driver. Obviously, you wouldn't look, but you could set up some algorithms to look for names that have a high probability of being a black person. Does a certain driver tend to reject those, more frequently? But to me, the big risk there, I'll just answer my question at the bottom right. Like, you got hundreds of thousands of drivers, you're going to get a bunch of false positives, right? And so how do you know what, there's going to be a few that just pop up by chance. Yeah, and
Did you tag the race of the driver?
So these are the things you don't think about when you're designing, right? This is the first question. Actually, okay, so second question today, right? This is the first question everyone asked, and we did not, for whatever reason, we didn't think of doing that, and then we had to get IRB approval. So we got it for part of the Seattle data set, and I don't think they got it at all for Boston, and we haven't analyzed those data. Yeah.
So for the comparison of the just say for accepted rate, just wonder other than the big effect of HRA, have you ever controlled for other things?
Other than the RA effects?
Yeah.
Yeah, we controlled. We sort of ran like a basic model. It was just sort of the group means model, which should be fine because it was a well-designed experiment. So you shouldn't need to worry about these other things. But for robustness, we ran a bunch of alternative specifications where, actually, I can't remember offhand. Certainly, like neighborhood characteristics. As I said, we looked at neighborhood density. I think we looked at proximity to a transit stop. A bunch of covariates. Crime rate, I think. Ran a bunch of sensitivity checks. And, the coefficient estimate bounces around a bit, but it's generally pretty consistent in indicating that there's this race effect. Yeah?
Curious about how more transparency would, in terms of, whatever we discussed was more information like causing problems. Right?
So this is like maybe the most controversial one. So more transparency would be like maybe like Lyft, maybe Uber should be showing photo and name up front or name up front. And there you're basically conceding that there's some people who want to discriminate and you're just letting them do it more easily. Now that sounds horrible, but the reason you might want to do that is that you just get it over with and you don't waste someone's time. So if you've got, so after this came out, we found, passengers reporting online, right, that, oh, the worst thing, he's like, I'm a black guy, I live in DC, I'm a black guy, but I have a white-sounding name. I can't tell you how many times I've called an Uber, and I stand out at the end of my street, and I see it pull up at the end of the block, and then when he sees who it is, he takes off and cancels the trip. So then you've wasted 5 minutes waiting, and you got to request a new one. So in that case, would you be better off if the guy just, forget it, he just declines the trip and it goes to someone who's not a racist bastard? And again, that's an oversimplification of, there's a lot of reasons that drivers do this. But I know we're short of time.
Do you want to do one more question?
Is there one more question? All right, cool, perfect. Sorry I didn't get to the third topic.